This is example 8.1 from Discovering Design with Chemistry. A chemist makes hydrogen gas according to the following chemical equation. You can read the equation. The chemist uses an excess of zinc and 150.0 grams of HCl. That means we know how much they're using of HCl, and they have plenty of zinc, so much that there's a leftover amount. So the HCl is going to be our limiting reactant and going to tell us how much we're going to get of the products. And when she collects the hydrogen gas, she finds she made 3.9 grams of it. What is her percent yield? So without that 3.9 grams, we could figure out how many grams she should have gotten, and then we can use that to figure out what our percent yield was. I just realized I spelled percent wrong, but this is a picture, so I can't change it. Okay, so let's start with, again, I like to make my conversion relationships first, so let's start with that one. Let's do the one that we're going to be working with. So we have HCl, we have 2 of those, and we care about the H2, and we have 1 of those. So whenever we figure out moles of one, we will need to use that conversion relationship to figure out moles of the other. So we're going to go from grams to moles to moles to grams. All right, so let's get the conversion relationship. So for HCl, 1 mole of HCl. Why am I like erasing this somehow? Is that right? All right, so to figure that out, we have to add 1.01 plus 35.45. And I got those off of the, oh, oops, should have made that a little bit bigger. Let's do that slowly. There we go. So we can add that up. And remember, we're adding, so significant figures tells us that we need to keep it at the hundredths place because both of these are the hundredths place. So 36.46. So that's our conversion relationship. 1 mole of HCl is 36.46 grams of HCl. Now let's do the other one. Let's take our H2 and figure out 1 mole of H2 is equal to, and that would be 2 times 01. So that is 2.02 grams of H2. So that is our conversion relationship for that one. So whenever we need conversion relationships, that is what's in this box right here. This is our conversion relationships box. Okay, so now that we have that, let's push the periodic table of elements to the side, and let's get to work on this. So we were given that she had 150.0 grams of HCl. We want to turn that into moles of HCl because moles is what the problem is working in. To do that, we need our conversion relationship that we found. So 150.0 grams times, and I did write my HCl up here, but I'm not going to write it down here. That's why I'm using colors. Oops. The word mole there. All right, so 1 mole is 36.46 grams. We have 4 significant figures in both of those numbers, so our answer is going to have 4 significant figures. All right, so we're going to have 4.114 moles. So 4.114 moles. That is how much the chemist used of the HCl in the problem. Now to figure out how many moles of H2 she got, we're going to need to use our conversion relationship here to convert moles of HCl to moles of H2. So 4.114, that's moles of HCl. I'm leaving out the word moles here, but I'm writing the elements so I can keep them straight. So 2 goes with this one, 1 goes with this one, and those will cancel out. And when we do this, remember we need to keep 4 significant digits because the 1 and the 2 are exact. So 4.114 divided by 2 gives us 2.057. So that's how many moles of H2 that she got, or she should have gotten, when she did this reaction. they told us how many grams she got, so we need to convert this moles into grams. You see in the process here, so 2.057, that's in moles of H2, but we're going to use our conversion relationship and turn our moles into grams. So this time we're using our conversion relationship there for moles. I guess I will label a little bit. It'll probably help. So 1 mole is 2.02 grams. This time we have 3 significant digits in one of the numbers that we're using. And so our answer is going to be limited to 3 significant digits. And so, oh, you know what? I have no idea why I just divided when I was supposed to multiply. Okay, so we need 3 significant digits. That means 4.1, and then we're going to round the 5 up to a 6. So 4.16, the moles canceled. This is grams of H2. So this is how much we should have ended up with in theory. This is our theoretical yield. But in actuality, in real life, we don't always get exactly what something is supposed to yield. And so to find our percent yield, what we're going to do is we're going to take our actual and we're going to divide it by the theoretical. And then to turn that into a percent, we'll just multiply by 100%. And so our actual, what she actually got, was told in the problem up here. She actually, I'm sort of on top of that. Oops, let's get rid of it. I made a little bit of a mess there. Okay, so what she actually got was 3.9 grams of it. So 3.9 is her actual yield. And then we calculated right here that she should have gotten 4.16 grams of this hydrogen gas. But to make this be a percent, we'll need to multiply it by 100% so that we can turn it into a percent. You can also just turn it into a percent in your head by moving the decimal. And we had 2 significant digits, so our answer can only have 2 significant digits. Let's go ahead and multiply this by 100. So we can only keep the tens place in the ones place, and we're going to have to round the rest. So this becomes 94%. So we have 94%. That's our percent yield. We followed the same pattern. You're done with the video. If you got that, just go ahead and turn it off. If you want to, again, review, what we did was we established our conversion relationships. That's the purple box. And then we took the grams that were given, converted it to moles using that conversion relationship, the red one. Then we took the moles of one substance and converted it to the moles of another using our purple equation conversion relationship. And then once we had the moles of the thing we actually cared about in the end, we used our last conversion relationship, the green one, to convert from moles of that substance to grams of that substance. And for this particular problem, they were looking for percent yield. So we took the number they gave us in the problem that was the actual yield and divided it by the theoretical yield that we got doing the math so that we could get that percent yield.